Alright, let's talk about adding vectors that are not all one dimension. Okay? So first go through the problem and find the vectors. Okay? A lot of people have a hard time reading and comprehending a word problem. The easiest way to make a word problem easier is to take out the important information and turn it into a numeric problem. So what I did first is went through and highlighted all of the vectors, meaning both the direction and the magnitude, or how much. Okay? Then I write it as an addition problem. Okay? So I have the first vector, 25 kilometers going east. Second vector is 9 kilometers going north. And the third vector is 43 kilometers going at an angle 40 degrees northeast. So this is when people start having a hard time. They're not all just x or just y. The third vector is both x and y at the same time. So what I like to do first is draw myself a picture. So east, we know, is going to the right. So give yourself some enough space. Now remember, I'm not drawing this to scale, but I'm going to try to make it the most realistic I can. Okay, so when I draw my 9, it's obviously going to be significantly shorter than my 25. When I draw my 43, I'm going to make it significantly longer than my 25. Okay, when you have something that's going northeast, if you draw your little compass here, this would be my 40 degrees northeast. Okay? Now we always do it with respect to the horizon when we're talking about northeast. The horizon, just in case you didn't know, is the horizontal line. So now I'm going to make a table to collect all of my x and y data. So it's the vector, the x component, and the y component. So I'm going to basically get rid of directions and angles, and I'm only going to use plus and minus. Okay, so vector number 1 is all in the x direction because it's horizontal. So the y direction, or y component, is going to be 0. Because it's going to the right, it's going to be positive 25. Vector number 2 is all in the y direction, or vertical direction, so the x component is 0. Because it's going north, it's going to be positive 9. The third vector is the more complicated one we have to figure out. We can't just look at it and say, oh, 43, let me see. I'm going to put 15 in x and 27 in y. Those aren't even real numbers. I'm just making things up, okay? What you have to do whenever you have something going on an angle, you have to find the component vectors. Okay, now remember, this is not drawn to scale, so you actually have to do math. How do I solve for both the x and the y direction? You gotta throw it back to your geometry years and do some SOHCAHTOA. The x is the adjacent side of the triangle. So when I'm finding the x, I'm going to use cosine. This is me doing the algebra already, okay? I know in order to get x, meaning the adjacent, by itself, I have to multiply both sides by the hypotenuse. If you need a refresher on this, check out one of my other videos about how to solve for sine and cosine, okay? For the y component, because it is the opposite side of the angle, I'm going to use the sine function times the hypotenuse. All right, so from here, get your handy dandy calculator out, right? Plug in your numbers. Remember, it's cosine of an angle. Make sure you close parentheses in your calculator before multiplying by the hypotenuse. Okay, find your x and y components. In this case, you want to keep the direction of each one either positive or negative. You don't have to worry about finding the angle at which it's going at. And I'm just going to round to 1 decimal place here. I know some teachers are very specific with sig figs, so do whatever your teacher wants you to do. If you are sig figs, then this is going to be 2 sig figs. Okay, because your x is going to the right and your y is going up, you know that both of those answers should be positive. Once you have your entire table filled in, then you're going